Okay guys, so I'm going to go over the solution for hemming. And these challenges as we go forward are going to get, as you can imagine, more challenging. So hemming is of course a little bit more difficult than the previous challenge, but it's not so outside of your ability. If you just applied what we learned in sessions and also did a little bit of research, which as I mentioned in class and also in previous videos, you're going to have to start doing as a coder, you guys could get to the solution. So we're going to start as we usually do with the Readme file. So I have the Readme file open here, and it says calculate the Hamming distance between two DNA strands. Your body is made up of cells that contain DNA. Those cells regularly wear out and need replacing, which they achieve by dividing into daughter cells. In fact, the average human body experiences over 10 quadrillion cell divisions in a lifetime. So a little bit of background information. When cells divide, their DNA replicates too. Sometimes during this process, mistakes happen, and single pieces of DNA get eroded with the incorrect information. If we compare two strands of DNA and count the differences between them, we can see how many mistakes occurred. This is known as the Hamming difference. We read DNA using the letters C, A, G, and T. Two strands might look like this. And they have an example here of two strands. Okay, this is a strand of DNA here in text form, and then this is another strand of DNA. Okay. Line 15 says they have 7 differences, and you can see the differences here. They're pointing to them here, okay? Therefore, the Hamming difference is 7. The Hamming difference is useful for lots of things in science, not just biology. So it's a nice phrase to be familiar with. Some implementation notes for the code. The Hamming distance is only defined for sequences of equal length. So an attempt to calculate it between sequences of different lengths should not work. The general handling of this situation, e.g. raising an exception versus returning a special value, may differ between languages. Okay, so a couple things. I think that a lot of the information back here is basically background, and it's nice to know, especially as you guys are learning STEM stuff. But for solving the problem, I think that mostly line 9 through, I guess, 22 is what you need to focus on. There's a couple things in here to focus on. The Hamming difference is only defined for sequences of equal length, so an attempt to calculate it between sequences of different length should not work. Also, we have in here the information that the DNA strand is just a bunch of letters, and we know we can store that data inside of a Python program just in a string. Okay, and they also showed you an example here of the difference between the strands, because we're starting from the beginning of the strand, and the difference is if you compare one character at a time, you can see where the differences is. So there's a C here, a G there, 2 A's here, so those are the same, a T here, a G here. So that's the information that we have, and I think that's a good start. So if we jump over to the code, which I have open here in Thony, I have the solution file and also the test file, and so open up in Thony. Okay, so we can start by thinking about the information that's going to come into our function and the information that we need to return. Hamming difference is going to be a number, right? And we're getting 2 strands of DNA. See, we have here the parameters. We have parameter 1. The first parameter is strand A, and the second parameter is strand B. So if we want to compare the individual characters in a strand, you guys have learned how to look at each individual thing in one string. So if I go over to mu, just to remind you guys, if I have a string, say my string, or if I say strand 1, A, and the strand is A, T, G, C. If I wanted to look at each letter in that strand, I could use a for loop. So we can say for letter in strand A, print letter. Okay, all right. So that's how you would look at each letter in the strand or in a string. All right. So now, what if we wanted to look at two different strings at the same time? Now you can do that because you guys know how to use the range function, and also you know that you can get the length of a strand, or length of a string rather. Alright, so if you've forgotten how to get a length, that's in one of the cheat sheets. So I jump over to cheat sheets, and I'm going to look at the shorter one. A couple things here. We can jump down to section on containers. LEN is how we get the length or the count of items. So if we use LEN, we can get the counts of items, and we can use that information with the information we have for the for loop. And also that information is right across from here. So LEN is how we get the count of a container, and a list is just a kind of container. It contains characters. And over here, we have, in this case, there's an example of a list. But a list is just another kind of container as well, except for the individual items are mutable, meaning that they can be changed. So here's the list that they have in this example. Okay? And then they're using the range function and the len function to go through the list one at a time based upon the length of the list. Okay? And we have an index here, and we are using that index to get the value of each item in this list. And we can do the same thing with a string. So I'm going to jump back over to REPL and can show you that. So in REPL, if we create another string, say strand B, and the strand B is equal to AATGC. Okay, so this is strand A, and this is strand B. Okay, so basically the same, or exactly the same. All right, so if I want to look at both of them at the same time, what I can do is use the len function, as I said. So if we say let's say for index and range, we get the len of strand A. It doesn't matter which strand we use because they have the same length. And remember from the Readme file, the Hamming distance is only defined for sequences of equal length, so the attempt to calculate it between sequences of different lengths should not work. So we have two strands that are the same length, so it doesn't really matter which one we get the length from, this should work, okay? In our example here, trying to figure out what code we should write. So we have the length, we can now print out both things. So we can say strand A, use the index, and tab, put a tab in between, and say strand B, index, okay? So this will print out each letter in our strand one at a time. It prints out the first letter and then the second letter. The first letter of both, and then the second letter of both, third letter of both, fourth, and then the fifth. So with this knowledge, we can actually solve a lot of our problem here because we can look at each letter at a time. And if we go back to the Readme file, since we can look at each letter at a time, we can see whether or not these things are equal or not. And then we can count when they aren't, okay? So if we are going to do that, what we need to do is keep track of the distance. So we should create a variable to hold the distance once we start adding to it. So let's call that variable something that makes sense. Let's call it the distance. That's what we will return. And it's just going to be an integer that we add to, okay? All right, so let's say distance at the beginning, before we've done anything, is going to be set to 0. If we don't find any differences between the two strands, then we're just going to return 0, right? So we're just going to return that distance. So we say return distance. So at the end, we're going to return the distance. So in between, we need to figure out if there's any differences, right? So we can do that with our for loop. So we can say for index in range len strand A. Then we can check if the strand A is not equal to the index is not equal to strand B at the index. Okay, whatever the index number is, because this is going to go from the way the range function works. We're going to go from 0 all the way up to the length of this, whatever the length is, assuming the strands are the same length, and then we'll stop. Okay, that's how the range function works. All right, so every time we go around, the index variable is assigned one of the numbers from 0 all the way up to the length of the string, okay? So if the strand A at the index does not equal strand B at the index, we're going to add 1 to our distance. So we're going to say distance plus equals 1. And you guys remember, this is just a short way of writing the variable distance equals distance plus 1, right? But if we can save ourselves from typing, we do. And this is just a quicker way of just adding 1 to the variable distance. At the beginning, it's set to 0. If we find any differences between the letters as we're going through, we're going to add 1. Okay? Then at the end, we can just return the distance. All right? And now that we think that we have a solution, what we can do is save this and run a test inside of Thony and see what we get. All right. We ran 9 tests and we got 2 failures. That's pretty good for our first attempt here. We only have 2 failures. Now, if we open up the terminal and do a test as well, so I'm going to do that. I'm going to open up the terminal and I'm going to cd over to the directory where I have these files. So projects and then challenges, and then we're going to go to Hamming. All right, so here are the files in the terminal, and as I've shown you before, we can do a PyTest, Hamming_test. All right, so if you scroll all the way up, you can actually see what passed, all right? You can see that a bunch of these tests actually passed, and we have 4 failures, as we saw in Thony. And you can see where the failures are. So this test is testing to make sure we paid attention to the Readme file. And the Readme file said, specifically, the Hamming distance is only defined for sequences of equal length, so an attempt to calculate it between sequences of different lengths should not work. In general, handling the situation, e.g. raising an exception versus returning a special value, may differ between languages. So it gives you a hint here of what it wants. It wants you to raise an exception. And we can go back to the terminal and we can see why we had some failures with the test. We didn't raise an exception when the distance was different. So the test script sent us a strand of length 4 and a strand of length 3. So we shouldn't be able to do the Hamming distance between these two strands because they're not the same length. So we need to raise a value error. This is the first test that failed. The second test that failed, similarly, we have a strand of no length and a strand of 1. We should raise a value error was not raised, so we need to raise a value error. So if we fix this part and raise our value error, we can solve our problem here, solve the challenge. Okay, so let me jump back over to our code in Thony and we can close out the shell. All right. So how do we raise a value error? This is the point at which you guys need to do some research, as I mentioned at the top. So you could do a Google search if you wanted to, but you could also just use the cheat sheet that we provided you. And we can use actually the shorter cheat sheet for this. On the first page here, there is some information about raising exceptions. As the README says, okay, you want to raise an exception, and it's right here. Exceptions on errors, you would use the raise keyword, okay? So if you want to, you can do a Google search on that. You can say raise Python error, and when you do a search, okay, all right, so it's showing you how to raise an exception. You just put raise exception and a message, okay? So that's a generic exception. You keep scrolling down, you can see you can have a type error. So let's play around with this a little bit. Based upon our Google search and doing a little bit of research, we just looked at a cheat sheet. We found that we could raise something and we can say exception. So let's do that, all right? So let's go back over to Thony. First, we need to check if the length is not the same, and that's when we need to raise the exception. So before we even start adding to our distance, we need to check whether or not the length of strand A is the same as the length of strand B. If it isn't, we need to raise that exception. So that's the first thing we need to do, because as the README file said, the Hamming distance doesn't make sense if the length is different. So we don't need to do anything if the length is different. So we've already figured out how to get the length of the string. It's right here with the len function. So we can use an if statement here at the beginning of our function. We can say if len of strand A does not equal len of strand B, raise an exception. Okay, let's just say length must be the same. All right, so we're going to raise an exception if the length is not the same. All right, so let me save this and see if that gets us any closer to our solution. I'm actually going to run the test in the terminal. So it doesn't seem to have solved our problem, and let's see why. Okay, go to the first one that failed. It says the type of error that it was expecting, apparently, was a value error. It wasn't expecting just a generic exception. Now, you can see that here in the test. And also, if we go back to our Google search, we could see that there are different kinds of exceptions that we could raise. We could raise a type error in this example, but we can also raise a value error. So how about we just make that small change? Just go back over here, and instead of raising a generic exception, let's change this to value error. Because that's what the test is looking for, because the values aren't what they should be. They should be exactly the same length, and they're not the same length, so we want to raise a specific error to tell the user of this function specifically what the issue is. Instead of just raising a generic exception, we want to give the user of the function as much information as possible so they can fix their code, okay? All right, so let's save this, and let's run the test again in terminal. Yeah, all 9 of our tests have passed. So that's all we really need to solve this problem. Now, we can clean this up a little bit and make this a little bit more Pythonic, meaning we can write this in a way to use some of the shortcuts that are inside of Python. Using the index and the length of the string is how you would write this in any language, but there are shortcuts inside of Python. And one of the things that you could use is the zip function. You can do some research on this. If you check the cheat sheet, there's a little bit of information on the zip function and all kinds of other functions that are useful for containers. So we have the len function, as we saw earlier in this cheat sheet, min, max, and sum, which sums things inside of a container. Min and max give the minimum and maximum. Sorted will sort a list. Enumerate, and then we have zip. Zip will combine 2 containers at the same index, okay? Which is basically what we want to do when going through these strands, is basically what we were doing as well. So we have the same index here, and we want to combine them. We're doing it manually here by getting the length of the strand and then using the index number. So So what we can do is replace this for loop with a for loop using one of the built-in functions inside of Python, specifically the zip function. So we can say for nucleotide A, and the letters inside of a strand of DNA are just nucleotides, and nucleotide B in zip. We're going to use the zip function. We're going to zip together strand A and strand B. So they're going to be zipped together at the index. So what we will do is get the first item in this strand, and this string rather. It'll be applied to this variable, the first item in this strand, or string. It will apply to this variable, and we can test whether or not they are equal with the same sort of if statement. Say if nucleotide A is not equal to nucleotide B, we're going to say distance plus equals 1, just like we did down there. Now, there are a couple advantages to doing this. First of all, it's a little bit easier to read what's going on here. We're using variable names that it makes sense within the context of the problem that we're trying to solve. So if strand A and strand B, and they're going to nucleotide A and nucleotide B, and we're checking to see whether or not the individual nucleotides are the same. If they're not, then we're going to add 1 to the distance. So we can get rid of this, because this is a little bit more difficult to read what is actually happening in our program. And we can save this, and I'm going to go back over to the terminal and run the test script again and see that we also pass. And that's it. It takes a little bit of research. I mean, you guys could have used the indexes to solve this, but this is a little bit more information if you did more research on the zip function, and you needed to do research on how to raise an exception to get the value errors sent over to the test. And that's the solution to this problem. All right, guys.